this is Gautam Puri from Career Launcher, and we'll continue with calculations and we'll focus on Vedic maths. Okay, that's what we are looking at. In the previous session, what did we cover? In the previous session, we had covered the base method of multiplication. Okay, and the base method of multiplication, effectively we said, if the number is 100 plus x and another number is 100 plus y, then, and if my base is 100, I will express this number as x and this number is y. On the right hand side, I will get x plus x into y, or the product of these two numbers, and on the left hand side, I will get 100 plus x plus y. Okay, simple, giving it the theoretical construct, but so from a calculation point of view, I am sure it is not going to be an issue for all those of you who have already gone through the previous session. This is just to get things into context. Now, what did I say last time? I said base has to be a power of 10. Okay? But if base has to be necessarily a power of 10, does it not make life a little difficult for us? Yes, it does. How? Because what if I have to multiply, let's say, 212 with 206? Can I take a base of 100? No. Can I take a base of 1000? No. Whether I take a base of 100 or 1000, it is not going to work for me for the simple reason it is going to make my calculation difficult. So, what is the ideal thing out here? I would want the base to be 200. Okay. So now let's move to the next phase of Vedic maths, which says actually any number can be your base. We started with a base equal to a power of 10 just to get the concept in place. Now I will go a step further and say any number can be your base. Okay. However, we have a base which is a power of 10, and we will have what we call a modified base. Okay. For example, if I have to multiply two numbers, let me take 307. Let's say I have to multiply it with 306. Let's just try to look at this one simple example. Okay. What will I say? What is the preferred base? The preferred base is 300. So, I will call my base as 3 into 100. Or my base is 100. My modified base is 3 into 100 equal to 300. It is not 300, I am again repeating. It is not 300, it is 3 into 100. Why is it important to say it is 3 into 100? Two reasons. The first reason is, since my original base is 100, this means I will retain two digits on the right hand side. And the second reason is 3, which I will talk about it in a couple of minutes. Okay. So, let us look at solving this question. We will do the same thing that we did earlier. Since my base is 100 into 3 equal to 300, so on a base of 100 into 3, this is plus 7. And on the base of 100 into 3, this is plus 6. Right hand side, same process, 7 into 6, 42. Right? What about left hand side? 307 plus 307 plus 6 multiplied with 3. Where has this 3 come from? From here. Whatever modification you have done on your base, the same modification is required on the left hand side also. We multiplied the base with 3, so we will multiply the left hand side also with 3. That's the simple rule we need to follow. So, what does left hand side become? 313 into 3 is 939. So, that's my answer. Simple process. So, I multiplied my base with 3. So, I multiplied the left hand side also with 3. That's the rule you will follow. So, whatever modification is done on the original base to create your modified base, the same modification is required on the left hand side also. So, let us do a couple of questions with a base of 200. I will take two cases, one more than 200, other case less than 200. Okay. So, 212 into 207. Okay. Base of 100, a modified base of 2 into 100 equal to 200. A modified base of 2 into 100 means that left hand side will have to be multiplied with 2, and right hand side should have 2 digits, because my base is 100, which means 2 zeros on the in it, and hence 2 digits on the right hand side. Okay. Plus 12 into plus 7, 84. Since my original base is 100, it is okay to keep 2 digits on the right hand side. Left hand side, 212 plus 7, 219. Original base was multiplied with 2, so I'll multiply the right hand side also, left hand side also with 2. So 438. 43884. Okay. Perfectly fine, I hope. Okay. One more example. Instead of 2, let's do 3 examples. Okay. 217 into 212. Same base, 2 into 100 plus 17 plus 12. What is 17 into 12? 170 plus 34, 204. So 04. 2 to be carried over. Left hand side, 217 plus 12, 229 into 2. Okay. Let me just change the color, or let me just highlight. This into 2 and this into 2. Okay. Plus 2. This carryover of 2. So this will be my left hand side. So 229 into 2 because the base has been multiplied with 2, so left hand side needs to be multiplied with 2, and there's a carryover of 2, that's an additional thing. Okay. So 229 into 2 makes it 458 plus 2, 460. So the answer will be 46004. Okay. Let's take a case of both numbers being less than the base. 182 into 187. Okay. 18 into 13. Minus 18 into minus 13. Again, base is, or let's say modified base is 2 into 100. Okay. So 182 into 187 is minus 18 into minus 13. 18 into 13 is 180 plus 54, 234. So right hand side becomes 34 and 2 to be carried over. Left hand side, 182 minus 13 makes it 169. 169th into 2. Into 2 because the base was multiplied with 2 to get the modified base. So left hand side will also be multiplied with 2 plus the carryover of 2. Okay. So what do we get? 169 into 2 makes it 338 plus 2, 340. So answer 34034. Okay. Take another case of base of 50. Okay. Let's go with the base of 50 now. Base of 50 is important because it will help you find the squares of numbers close to 50 also, but that's a session we will do separately. Okay. But just to understand the concept. Now the interesting thing about base of 50 is you can get a base of 50 by 2 different ways. One could be 100 by 2. Another could be 10 into 5. Here my original base is 100. Here my original base is 10. In this case, my original base is 100. So I could get 50 as 10 into 2 or 100 by 2. 10 into 5 or 100 into 2. There are two ways of getting 50. Let's try to do the question with both the methods. Okay. Let's take 53 into 57. Okay. On a base of 100 in 10 into 5, this is plus 3 plus 7. Similarly, if you look at the same number 53 into 57, no difference so far. Where will the difference arise? Two places. The first place where the difference is how many dates on the right hand side. In this case, base of 10 into 5 equal to 50, number of dates on the right hand side can be only 1 because it is 10 to power 1. And in this case, the number of dates on the right hand side will have to be 2 because the original base is 100. Right? So 7 into 3, 21. Retain 1, 2 to be carried over. What about here? 7 into 3, 21. We can retain 2 digits because the original base is 100. Left hand side, 53 plus 7, 60. Since the original base has been multiplied with 5, I will multiply this also with 5. What about here? 53 into 7, 53 plus 7, 60. Since the original base has been divided by 2, this will also be divided by 2. So 3021. And what about this? 60 into 5, 300 plus carryover of 2, 302. Same answer. So you need to be clear that the method is very, very robust and you can work with any base which you want. However, my suggestion would always be to go for 100 by 2 rather than 10 into 5, because this dividing by 2 I always find it easier. If you find multiplying with 5 easier, that's fine, you can go with that also. Okay, but if you have to do, let's say, 64 into 62, then probably a 10 by 10 into 6 might be an easier option for you, but I'll leave that call to you. Okay. Okay. Continuing with the same thing of base of 50. Let's look at a couple of numbers less than, let's say 50. Okay. 42 into 46. Base of 100 by 2 equal to 50, which again I will emphasize, 2 digits on the right hand side and whatever you get on the left hand side has to be divided by 2. Okay. Minus 8, minus 4, 8 4s are 32, 42 minus 4 is 38, absolutely right. 38 divided by 2, 1932. Okay. One more example. Okay. We'll take a smaller number so that the calculation becomes bigger. 32 into 36, let's check. Minus 18 into minus 14. Oh, I think we have done that earlier, isn't it? Yeah, minus 18 into minus 14 is, no, we did 18 into 13. Okay, nevertheless, minus 18 into minus 14 is 180 plus 32. Okay, so no, not 32, minus 18 into minus 14, 180 plus 72. My mistake, I am sorry. So 18 into 10 plus 18 into 4. What is 18 into 4? 18 into 2 into 2, 36, 18 into 2, 36 into 2, 72. So 252. So minus 18 into minus 14 is 252. Since we are working on a base of 100 by 2 equal to 50, you will retain 2 digits with you and the third digit will have to be carried over to the left hand side. Left hand side will be 32 minus 14 is going to be 18. Since the original base was divided by 2, left hand side needs to be divided by 2. 18 by 2 is 9 plus 2, 11. Okay. So this is the basic calculation that you need to master. Okay. And again I will repeat, this should not be done. This all stuff is an oral item. Okay. All this which is highlighted is something which has to be done orally, and the only thing that you should be writing is this. This is the only thing that you should be writing. That's all from my side for today. Okay. That's all from my side for today. Please practice whatever we have done. It is important that you practice, and as you can see, you don't need to do anything special. Just look at numbers, random numbers, multiply it, and get used to it. Okay. So all the best.